Hello, I am Supreetha. Welcome to my math class. So in this class, let us study something about set theory. So you study set theory not only in your 11th or 10th grade, it is also used in the preparation for JEE and CSIR NET exams. Okay, so what is a set? A set is a well-defined collection of objects. Yes, so what is this collection of objects if you ask me? So when do you use this word collection? So for example, on my table I have a collection of books. Yes, so that is a set. I have collection of pens. Yes, so that is a set. I can call that as a set. Now if I take this PC, yes, my PC, if I say that this is a set, what would be the elements of this set? That would be the monitor, the keyboard and the mouse, right? So yes, the objects that constitutes a set is called as elements. Okay, so I can write PC. What are the elements of PC? I said monitor, keyboard, and then the mouse. So there are two ways of representing a set. Okay, so the first one is the roster method or the roster way, and the second one is the property. Okay, property method or the property way. Okay, so how do you represent a set using roster method? Imagine I have a set A which contains even numbers 2, 4 and 6. Okay, so in roster method you write the elements inside curly braces, separating every element with a comma. Okay, so in property method, let me take a set in roster method itself. 1, 2, 3 and 4. Okay, so I give some properties that would define the set. Okay, how can I write that? So let me take X. Okay, X is an element that belongs to this set A. Okay, such that this colon is called as such that 1 is less than or equal to X less than or equal to 4. So I hope you know that this represents this 1, 2, 3, 4. Yes? Okay. Moving on, let us study something about different types of sets. Okay. So the first one is finite set. Have you heard the word finite? What do you mean by it? Finite means something that can be counted, right? So for example, I have a set of books on my table. I have 4 books that can be counted. I have 4 pens which can be counted. So all these are finite set. Yes? Set of books, pens, etc. Okay, now what is an infinite set? What is an infinite set? Infinite set is a set in which the elements cannot be counted. Okay, for example, can you think of any examples now? Yes. Can you count the number of stars? No, right? Okay. Number of stars cannot be counted. So that would be an infinite set. What is this symbol? Doesn't this represent the set of natural numbers? Yes. So can the natural numbers be counted? No, right? So that is an infinite set. Next, let us study something about subset. Okay. Now, what is the subset? Imagine I have a set A. Okay. It has elements 1, 2, 3, and 4. Let me take some more. 5, 6. Let me write a set B. I say B is a subset of A. Okay. B is a subset of A. What does this mean? What can you observe over here from B and A? You see, B has elements such as 1, 2, and 3. Are these 1, 2, and 3 present in the set A? Yes. That is the reason we call B is a subset of A. So basically, all the elements of B should be present in A. It is not necessary that all the elements of A must be present in B. Yes. So I cannot write A is subset of B. Okay. I am writing B is a subset of A. All the elements of B are present in A. A is not a subset of B. Okay. So let me give you some questions now. Can you answer them? Let me take a set C that contains 3, 5, and 6. Is this a subset of A? Is 3, 5, 6 present in A? Yes, you have 3 over here, you have 5 and 6. So C is a subset of A. Next, let me take a set D. Is this a subset of A? 1, 7, and 8? Let me check. Is 1 present in A? Yes. Is 7 present in A? No. Right? So this is not a subset of A. Okay. Now, let me give you an example if you still did not understand this. Okay. Now I have my table. Yes. Let me take this table as a set. Okay. So there are books, as I told you, books, pens, and my PC. So now, if I take another set of the books, yes, books is present on the table. So books is a subset of this table, I can tell. Yes. Now what if I take another set of chairs? Are these chairs present on the table? No, right? So chairs can't be a subset of the table. Okay. Moving on, let us study something about power sets. What do you mean by a power set? A power set is a set which contains all possible subsets of a given set. Okay. Let me take an example for that. Let me take A is equal to A1, A2. Yes. So what would be the power set? Okay. So firstly, before studying this, let us study something about the null set. Okay. What is a null set? Have you heard the word null? Basically, null set means an empty set. A set which has no elements. Okay. It is also denoted by this symbol. Okay. Next, a singleton set. Yes. A singleton set means, as the name specifies, the set contains only a single element. Okay. So A is equal to A means this is a singleton set. Let us get back to our power set. Yes. What did I tell you? What was a power set? A power set basically contains all possible subsets of a given set. Now they have given us a set that is A is equal to A1 and A2. What are the possible subsets of this set? Null set? Yes. If I take this, let me take back the table example. There can be nothing on the table. The table can be empty. Yes. The subset can contain only the element A1. It can contain only A2. Or it can contain both A1 and A2. Yes. Okay. So there is a formula to find out the possible number of subsets a power set can have. Yes, a possible number of subsets a given set can have. Yes. So the number of sets the given set A can have is 2 to the power R, where R represents the number of elements in the set A. Okay. So how many number of elements does the set A contains? 2, right? So that would be 2 square, which is equal to 4. Does this set contain 4 subsets? Yes, 1, 2, 3 and 4. Yes. So what did we study in this class? We studied about the definition of set theory, which was a set is a well-defined collection of objects. We took the example of this table. Yes, there are 2 ways of representing a set. That is the roster method, in which every element is separated using comma inside curly braces. Okay, and then comes the property method, where you specify the property of the given set. Okay, and then we studied about finite set. Yes, so the word finite itself says that the number of elements in the set is finite. Yes, and then comes the infinite set, that is the elements of the set are infinite. Null set, that is an empty set, and singleton set, which has only one element. Yes, what was a subset? So if every element of B is present in the given set, then I can write B is a subset of A. Okay. Then what was a power set? A power set is a set which contains all possible subsets of a given set. Okay. So moving on, let us study something about Venn diagram. Okay. So what is a Venn diagram? Imagine you have a set A. Okay. You have a set A which is equal to 1, 2, 3 and 4. So how do you represent this in a Venn diagram? Yes, a Venn diagram can simply be written as, you take a circle, inside that you write 1, 2, 3 and 4. So this is a set A. This is a Venn diagram. Okay. Now let us study something about algebra on sets. Okay. So what comes to your mind when I tell you the word algebra? Addition, subtraction, multiplication and division, is it? You see, in the set theory, in this algebra on sets, we study something about union, intersection and complement. Okay. So what is this union? What do you mean by a union? The word union. Where something meets, right? Let me take the set 1, 2 and 3. Okay. Let me take another set 3, 4 and 5. Okay. Now let me draw a Venn diagram for this. Yes. Now let me say that this is the set A and this is the set B. Okay. So now I write 1 and 2 over here. You see this part it represents the union, right? How? Because see, this is A and this is B. Both of these are intersecting, right? So if I write 3 over here, 3 belongs to the set A and the set B, right? So I'll write the remaining terms, that is 4 and 5 over here. Okay. So if I say that A and B, the union of A and B would be, you just write all the elements that is in the set A and all the elements that is present in set B. So in the Venn diagram, the whole thing, 1, 2, 3, 4 and 5, the whole thing represents A union B. Next, what do you mean by intersection? Okay, what do you mean by the word intersection? So intersection basically means, let me take the same example, A intersection B. This is the symbol that denotes intersection and this is the symbol that denotes union. Okay, so A intersection B is, you write only the common terms from the sets A and B. Now, which is that common term? 3, right? So again, let me draw the Venn diagram, the same Venn diagram. So where do you shade? Which part do you shade? Yes. So again, A and B, A, B, and then 1, 2, 3, 4, and 5. Shade the part that contains 3. This part, isn't it? So this represents the intersection of two sets. Okay, now what is the complement of a set? Again, let me take the same example. Okay, so if I have to write A complement B, I would have to write like this. Okay, this symbol represents A complement B. So I'd have to write all the elements of A. Okay, but subtract the elements that are present in B. What I mean is, I would write only 1 and 2, but I wouldn't write 3 because that is present in B. Okay. So what is a union of a set? You just unite, okay, or you just all the elements that are present in A and B, you write that as a set. Yes, that is the union. So this is the symbol that denotes union of a set. And what is intersection? Intersection is nothing but you write a set, okay, that is the common elements of A and B. Okay, you represent that as a set, that is 3 over here. Yes, what is complement of a set? If I write A complement B, that would be you write all the elements of A, but you discard the elements that are common to B. Yes, so I wrote only 1 and 2. I did not write 3 because that is common in A and B. What would B complement A be now? B complement A would be 4, 5, right? So if I take the Venn diagram, here, this part would be A complement B, yes, and this part would be B complement A. Agree? Moving on to the last topic, that is Cartesian product. What is this Cartesian product? Cartesian product. Yes. So if A and B is a set, the Cartesian product of A and B is denoted by A cross B. Okay. So now an ordered pair x comma y is said to be Now, if we have two sets, say A and B, then Cartesian product of A and B is denoted by A cross B. Yes. So now this set A cross B contains elements in the ordered pair, in the form of ordered pair, say x comma y, such that x belongs to the set A and y belongs to the set B. Yes. Now let me take an example. Now let A is equal to 1 and 2. Yes. And B is equal to 3, 4. Now what would A cross B be? Yes, A cross B is equal to multiply. I would get 1, 3. Yes, and I would get 1, 4. Okay, and then 2, 3 and 2, 4. Okay, so what would B cross A be? That would be 3, 1, 3, 2. Yes, you just write it in the form of ordered pair. Okay, we are doing B cross A, so it would be 3, 1, 3, 2, and then 4, 1 and 4, 2. Yes, so can you see that these both aren't equal? So can I write they are not commutative, or A cross B is not equal to B cross A? Right? Now what if I have A cross B union C? How would I write this? I would write this as A cross B union A cross C. Now how did you get this? Take another set C, something like 4, 5, and can you try this? Yes. So now what did we study? Again, let me just revise. We studied about Venn diagram, where you represent the elements of a set inside a circle. Yes. And then we studied about algebra on sets, union, intersection and complement. Yes. Later on we studied about the Cartesian product. Okay. So yes, that's it for today. Thank you.